Oh, we're on. Oh, this is the video that I just did uploading. You don't need to see that. What you're going? What is that all about? Okay, but now let's go ahead and let's take a look at when we're not in free fall. And this is the vomit comet. This is actually we're going to watch these weightlessness on the vomit comet. Basically, what this is an airplane that goes up really fast, and then it does a dive so that it equals when it's in its free fall, it equals about 9.8 meters per second squared in its acceleration. So everything is falling at the same rate as the plane inside the plane, so that everything becomes apparently weightless. All right, and so you get some interesting.
In this sequence are shown experiments of simulated weightlessness, or zero-G. To produce this weightless state, an aircraft, in this case a Convair C-131, is flown through a Capillarian trajectory. Starting at 12,000 feet, the aircraft goes into a 10-degree dive until a speed of 250 knots is reached. After a pull-up at 2.5 G, a 35-degree climb results in 15 seconds at 0 G. The maneuver ends with a 35-degree dive and pull-out at 10,500 feet. In these experiments, you can see the disorientation resulting when an animal is suddenly placed in a weightless state. Cats, when dropped under normal conditions, will invariably rotate their bodies longitudinally in midair and land on their feet. This automatic reflex action is almost completely lost under weightlessness.
Oh God, I hate buffering. Poor cat. Now watch. Bang! Kicks it right into the
Pigeons
board.
normally keep their bodies in a horizontal axis while in flight. These zero-G birds have lost their feeling for what is up or down and point in all directions, some even flying upside down.
Okay, so we don't need to see the cats taking off. All right, so I'm going to show you the hammer and feather drop. This is another short where we look at actually what gravity is. Hopefully there won't be a whole lot of buffering on this one. This is, I think this was in 1970, 71.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time.
And they did.
How about that? Which proves that Mr. Galileo was correct in his findings.
Okay, now the reason that was successful, now some of you are going, wait a minute, why did it work on the moon and not here? Well, the reason it works on the moon is because there's no atmosphere. All right, and so when they drop the feather, it's falling at the same rate as the hammer. Okay, the question is, which one would you rather have hit you? Well, of course, the feather, because it's got less mass, so it wouldn't hurt as bad. The force that it would hit you, the stopping force would not be so hard. And then, so anyway, well, let's take a look at this. I really like this guy. Misconceptions of falling objects. Okay, so this Veritasium guy, he's really good. This is sight unseen, but we're gonna watch it.
Let's say Jack holds both balls above his head, and then he drops them at exactly the same time. What do you expect to see?
Well, they're going to hit the ground at the same time. I expect them to both land at the same time.
Same time.
Same time.
Well, I think they both will.
This one to hit the ground first. However, they would actually both hit the ground at the same time.
Yeah. Why is that?
Science.
Yeah, science.
Now, the black one clearly feels a lot heavier.
So the standard misconception is to believe that the black ball will accelerate at a
Oh
greater rate
shoot, this is
and reach the
terrible.
ground first.
This is terrible.
This
Let
year,
me get out of
many
this.
people had an idea that both.
All right. Okay, so you get an idea of the weightless. I'm going to